Hi, I've done this video for helping you when solving problems, okay? So, when you face into a problem, you have to take into account the data, okay? And you have to be capable to distinguish, okay, the kind of problem or what formula, which one of these one is the one that you have to use, the one or the one, okay? This is really important because when you face into a problem, the problem is not going to tell you which one do you have to choose, okay? So you have to look the data, okay? Look for the data into the problem. And if the data, here I have written the data, okay? The data of the problem, and here the possible data, okay? And here are the formula. So, if the problems, the data is deformation, the deformation of a spring, okay? You have to choose this one. If the data is the position, the speed, or the time, okay, you have to choose this one because there's no acceleration. If the data is speed, time, or acceleration, okay, but here it's going to say you the speed and the time, and you can calculate the acceleration. You have to take into account that maybe it's an accelerated movement, but the data is not the acceleration because maybe you have to calculate the acceleration, and the data is going to be the final velocity and the initial velocity and the time, so you can calculate the acceleration. Next one, this one, we are going to use it, okay? If the data is the mass or the force, okay, take this into account. If the problem says you the force or the mass or the acceleration, okay, sometimes in these problems what happens is that they give you the force and the mass of the object. For example, we have an object with a mass of 5 kilograms and we apply a force of 5 newtons, okay? So with the force and the mass, you can calculate the acceleration that that object is going to take when we push it. So after this, you can also calculate with the data of the acceleration, you can calculate with this formula the final velocity of that object. Because if this object weighs 5 kilograms and I push it with a force of 5 newtons, okay, it is going to start moving with an acceleration. That acceleration is going to be, for example, I'm not going to do the calculate, okay, but imagine that the acceleration is 10 meters per square second, okay, so that's really fast. With that data, you can substitute in the equation and the acceleration, you have calculated here, okay? So you can calculate the final velocity if you know for the time, for example, after 10 seconds. You can calculate after 10 seconds with the data of the acceleration, you can calculate the final velocity because the initial velocity, obviously, it's 0 because it was stopped and you push it. Okay, that is going to be this kind of problems, more or less. I'm going to do another one later for solving it. Then, if a problem gives you the mass and the distance of two objects, okay, two objects, just write it, two objects, you have to choose this one because it's force with the gravity constant, mass, the mass of one of the objects and the mass of the other object and the distance, okay? In this one, electric force, if it gives you the charge of a particle, okay, the charge, is this one, obviously. No, distance and force, okay, maybe it's the data are going to be distance and force, but you have to take into account that if the problem is giving you the charge of a particle, obviously it's this one. Okay, and finally, for energy, how to not mistake this one from this one. It's really easy. Sometimes you have problems when distinguishing the energy problems with this kind of problems of motion, okay? So you have to take into account that when you are solving an energy problem, in the data is going to be the energy or the height or maybe the mass, okay? And it's going to be there in the data, or maybe the problem is asking you for calculating the energy or kinetic energy or the total energy. So and in most cases these problems are going to be about this is the floor, this is a building, and this is an object with mass, okay, 1 kilogram, that is going to fall down, okay? So what is going to happen here at the beginning, when it's not falling yet, it's going to have only potential energy, okay? And the potential energy is going to be the mass, 1 kilogram, times the gravity, constant gravity, that this one, take into account that this one is not the same as this one. This is the universal constant gravity, which is for everywhere. And this one is gravity on Earth. In this case, we are on Earth, okay? This is 9.8, or no, 9.98. And the height, okay, is going to tell you the height of the building, which is maybe 20 meters. Okay, at the beginning it only has potential energy, it's stopped yet, but when the object is going to start falling down, okay, what is going to happen? That, look at this, potential energy equals the mass times gravity and height. The height is going down, so the height is going to be lower and lower as it falls down, okay? So it's going to lose potential energy, but it's going to gain kinetical energy, okay? Because it starts moving, and here is velocity. So when the object is here, it has both potential and both kinetic energy, because it has velocity, it's moving, okay? But just we are going to see this in the next lesson, okay? But maybe you can look back this video in the next lesson for distinguishing this kind of exercises from these other ones. And so more or less this is all what you have to take into account when solving problems. You have to take into account the data, okay? Just look for the data, the kind of data they are giving you. And so that's all, okay?